Welcome back. Today I want to start some financial modeling, first in Excel and later using Python. I started by putting in a few securities, and I'll talk about these different parameters in a minute. And the aim of this exercise is to derive the yield to maturity. We already spoke about the yield to maturity, and we also derived a formula for annuities, which we use in this example as well. So the idea is the following. When we look at a fixed income security, for instance security A, we have to consider a coupon rate which is paid semi-annually. We have to consider the maturity, in this case only 1 year, the par value, so that's the value we would use to calculate our interest payment, the current price of a security, and then maybe some portfolio weight. Now at the moment we don't focus at the portfolio allocation, we will do this in a later session. Our focus is now to derive the yield to maturity for each security on that spreadsheet. Of course, the spreadsheet and all the solutions are available. Let's get into this and first remind us what we are doing here analytically. So when we think about this problem, what we try to achieve is the following. We have the price of a security, and I just might maybe consider the following. So we have a price of a security, which I denote as, for instance, PT. And we then have to consider these coupon payments. Now, as I mentioned before, the coupon rate would be, of course, a percentage relative to par value. So what we do is we take our coupon rate, C in this case, we multiply this with our par value. I just call this par. And then we have to divide this by 200, because the coupon rate is in percentage, so we divide by 100 and we have semi-annual payments. So this would be the value of a payment, not to be precise, actually that's the actual value of a payment. And then of course we have to do some discounting with it. So this is the payments we get. And we do get now these several times. So in our case, we would need to do a discount factor here, and we have to discount according to the timing of it. So at the moment, of course, we don't know the discount rate because that's our yield to maturity. So I just denote this as R. So that's for the first payment, and then we have a second payment because it's semi-annual in this case. So it's something like 1 plus R and then to the power of 2. And at the end of the maturity we also get our principal back, which would be our par. So that's our principal value, which also has to be discounted accordingly. So it would be 1 plus R power of 2. So that's basically what we are doing. Then of course you also remember we had a formula for that, so we basically simplified our calculation using a formula for the second term in this equation. So we looked at this in more detail and we derived a formula for that, which basically states the following, that it's 1 divided by my discount rate, 1 minus 1 divided by 1 plus R up to maturity T. So that's maturity T. And of course I have to think carefully about how many payments I have. So of course in our initial case we have now semi-annual payments, so we have to adjust that accordingly, but you will see this in a minute in the actual equations. But that's the background of what we try to achieve. Now, the yield to maturity is an internal rate of return for the bond, assuming that you hold the security until maturity. Now, this is of course only a conceptual, a conceptual framework, because it's quite often the case that you might sell this security beforehand. But depending on the type of investor, in particular long-term investors, they might really hold to maturity. So it is still a useful metric to derive. Now what you see in Excel is I now used that equation in two different ways. So once I actually used our derived equation because this is more convenient for calculation, and then I build up the equation as you see above. Yes, building up this equation as a series is fine. However, if you have higher and higher maturities, this becomes quite cumbersome and painful to write. So what I have done here is I derived in this particular cell the equation. And now to explore this a bit further, let me just zoom. And look into this equation in a bit more detail. Now what I have done is exactly what you see in the equation above. The only difference is I repeated this part twice. This is of course unnecessary. You could move that out of the equation if you want to. The only thing, the only reason why I have done this is because I put in also directly the par value in here. So that's a matter of taste how you want to write this. So again, we have the coupon rate. This is your B9 cell, which I multiply by D9, which is the par value. I divide by 200. So this gives me the payment for each and every interest payment. Then I discount with 1 plus G9 half, again because we adjust for the fact that we have semi-annual payments. And this G9 is your target, your yield to maturity. Yeah, we don't initially know that, so we would start with a low value and would use a numeric method to actually find that. And I'll show you this in a minute. And then we have the second part, and here we also have to add our par value, so we get the principal back, and we have to do some discounting now to the power of 2, because that's in 1 year's time, and we have semi-annual payments. And at the end we subtract the current price. Now the idea of yield to maturity is that we have to find G9, so the yield to maturity, that ensures that the current price is reflected. So put differently, if I take these discounted cash flows, they have to be equal to the current price. Or if I subtract the price, this expression has to be equal to 0. So that would be my target function for optimization. So that is the idea. I repeated the idea in this equation here, where I use the formula we derived. Yeah, so again you see our payments. So this is the coupon payment. I adjust for percentages and semi-annual payments. I multiply by the par value, and I do the initial discounting by R. We see this in the equation. And then I have the second part of the equation, where I do the adjustment 2 times maturity for semi-annual payments. And that again would be equal to the price. It's just to see whether this formula is indeed equal to the price we see reflected here using the solved yield to maturity. Good. Now let's try to actually find this. We of course already found here the solution, so I change it now to maybe 2%. Yeah. So once you change it to 2%, you see obviously that the price suggested by our asset pricing model would go above the actual price. Yeah. So this yield to maturity is not the right one. it's too low. Yeah, and also here you see you're not equal to 0, so that has to be equal to 0. So how do we find in Excel the yield to maturity? Now what we do is we go to the tab that is denoted data, and in the right hand side you see the solver. Now if you do not see the solver in your version of Excel, you haven't activated it. Yeah? In order to activate the solver, you head over here, go to options and go to add-ins and select the analysis tool pack, and you just say go. Yeah, so it will be inactive, so it will be somewhere down there. You just say go and you would tick the box and you would say OK. Now in our case the box is ticked for the solver add-in, so we have it already activated, so we can work with it. Yeah, but make sure it's activated in your case. Now we go to the solver and we define an objective. Yeah, there are different things we could consider, but what I have done is I basically went into this cell here, because this has to be equal to 0 based on our assessment. So I select value of 0 by changing the following cell, which is this cell here, which is my target yield to maturity. I don't specify any further constraints. Again, this might be necessary under certain conditions, and I try to solve it. Yeah, and in this particular case, you see that the solver found a solution, and you just say OK. And now we have our result here, 11.52, and you see that this term vanishes, is equal to 0, and our formula gives exactly the current price. Yeah, so this is how we have derived the yield to maturity in Excel. I see you in the next